welcome everybody. I'm David Lowe, one of the librarians here at Evans Library, and we're overjoyed to have you all here at one of our GradTrack series events. And tonight we're talking about blockchains. Dr. Marius Silaghi, he's faculty in the School of Computing here at Florida Tech. He teaches and conducts research in cryptography and cryptographic protocols for distributed artificial intelligence. He's been doing this for about 20 years, and he's interested in secure and decentralized support for organizations. He got his PhD from the Swiss Federal Institute of Technology in 2002. In this particular event, I believe it was last semester, we were talking about what topics we should have, and you said blockchain, and I said, well, you do it, and you said yes, so we're lucky to have you. Thank you very much.
Yeah, so my talk is entitled Blockchain Promises to Address Democracy. And actually we'll go behind and beyond the Bitcoin a little bit. So we'll start smoothly. So first, what is a hash? You may have some indexes where you can put things, right here from 0 to 15, right? The pages where you can put texts, let's say. Okay? So a hash function, it's a scheme to associate a text with an index, with a number. Okay? And there are typically more possible texts than possible indexes. Therefore, sometimes we have collisions, like John Smith and Sandra Dee may both get position number 2. Trivial hash, a trivial way to associate would be to just add each byte in the text, like each character in the text, it's an ASCII code, it's a number, you add all of them, you get a number, and that's the position when you are going to put your text. That would be a trivial hash. Not a very interesting one. We are going to look further to the next level. It's a concept of secure cryptographic hash, which says that a given text will go to a bigger digest, a bigger hash number. So rather than the indexes you had 1 from 15, now you have big numbers like this one here in hexadecimals, right? They are also called digests. Cryptographic hashes are one-way functions. It means typically if you go in one way, it's easy, you compute the cryptographic hash as a function. Going backward is something very complicated. It should be very hard, practically impossible for somebody to do. And more than being impossible to go that way, or very hard, it is very hard to find two texts that have the same digest. So it's very hard to find a collision. We know for certain that there exists because there are more possible texts than digests of this size, but it's going to be very hard to find them. How is a cryptographic or a secure hash typically computed? You take the message, you break it in blocks. For each message block, you apply a function which consists in rotations, additions, permutations of bits, and eventually you do that mixing all the blocks, and you are going to get a cryptographic hash. Okay, now the first application of these cryptographic hashes would be commitment to contracts. Right? So, when you want to commit to a contract, you could go and notarize it. But rather than going and notarizing it, you could compute its hash and just commit to its hash, or notarize the hash of the contract. If you notarize to the hash, you know that actually you notarize to the contract whose cryptographic digest is the hash. And if the hash is secured, is proven that you committed to it, it would be difficult to invent another contract with the same hash. And you cannot fail, you cannot come with two contracts with the same hashes to get one of them notarized and to come out and later to say, this other contract was a real one. So the secure hashes guarantee us that we can simply notarize the hashes. Don't have to put full contracts there. Okay? So it's enough to store the hash of the document. And this gives a kind of privacy you might have heard about with bitcoins and blockchains. Okay? So there's the privacy in the sense that from a text you can get the hash. If you notarize the hash, everybody may see the hash, but nobody may actually see the contract. And you can reveal the contract if you want and say, oh, you see, I have this contract committed, or you may hide it, and then nobody knows about the existence of the contract until you reveal it. Merkle trees are important concepts here used in blockchains. If you have many documents and you want to compute a hash of all of these documents, such that you commit to all of them once, one idea is you compute the hash for each document separately, then the hash of 2 documents is joined into one hash, then the hash of 2 other hashes are joined into one hash. Like that, you can parallelize the hashing of many documents. It's relatively easy to add a new one. You just add in, go upward. And to verify a hash, you only need to know the path from the root of the tree to the document that you are verifying. So it's enough to verify, to know these 2 hashes, to verify the top hash, then to know these 2, and then to know this document. And you don't need to know the rest of the elements in the tree. And now if you want to store a history of contracts, okay, you can do that by adding the hash of all contracts into the set of documents whose hash you are computing now as the new documents. So you get a chain of hashes. No? At the beginning, there's the very first round, there are no old hashes, so you put just 0 for the old documents, and you have just the new documents in a Merkle tree that generate you a hash. Then, for the next time step, when you add new documents, you also, besides the new documents, you compute their hash, you also add the hash of the old documents. And like that, you continuously add all the old documents into new contracts, and you keep a history of all the documents. Okay? The first block here is called the genesis block, and you can keep on. This is a chain of hashes, it's a blockchain. As a blockchain, it's what you have heard so far, with a few small details. That's an older concept, it was around for many years. It's a small grain of salt that was brought to blockchain to make it into what you've heard so far. It comes from the next idea. Well, finding a document with a given hash value is hard. We have seen, the hash is big, you would have to try enormously many documents to find one. It would be impossible. So, one has here a random number that you add in each block, besides the current documents and the old documents, and a timestamp to know where when the documents are actually added to the notarization chain. You also add this random number. And you could try multiple values of this random number until the hash has a value you want. But it would be very difficult, because the hash has this one-way property. It says that it should be impossible to try all possible values to get the one hash you want. That's impossible. But if you don't try to find a block document with a given hash, but rather documents with a hash whose value is smaller than a threshold. Okay? How can it be smaller than a threshold? For example, if the first bytes are 0, it means, right? It means that actually you have a digest that is smaller than this value over here. Right? So you have 2 zeros and then 8646. So this is a digest smaller than 0, 1, 0, 0, 0, 0, 0, right? Is it difficult to generate such hashes? Well, if you just want the first byte to be 0, you have 256 possibilities, right? So the number of trials you need to do to get a digest where just the first byte is 0 is relatively small, right? To generate 2 by 0 a little bit more difficult, and so on. So the more zeros you want at the beginning, the more difficult it is. So you can set such a threshold to control the difficulty of generating a hash with this property of being smaller than your threshold. The smaller the threshold, the more difficult it is to generate a hash that is smaller than that threshold. Okay? And now you can decide such threshold and search for a random document to be added here, besides all the other documents you're notarizing, such that the difficulty is the one you want. In the case of Bitcoin, 10-minute search, even with all the computers that are currently working to find the hash. So each few weeks, each couple of weeks, there's a computation of an estimation of how many computers are computing bitcoins based on the speed it works. You divide the amount of work you need to find a hash with this property by the number of by the power of the computers out there that are doing it, and you find the threshold that is needed such that you guarantee that it needs about 10 minutes to find one. So that's how the blockchain for Bitcoin works. Okay? For other kinds of coins, the threshold is computed such that the amount of computation you need is probably 4 minutes or a few seconds, so on. So in Bitcoin, for example, the threshold is selected every 2 weeks, such that you have this constant about 10 minutes amount of work needed to generate a new block. And like that, each about 10 minutes, you can notarize a new set of documents. So what are the miners doing there? There's a competition that happens between all people owning computers that want to work for the blockchain. Each of them tries to find a nonce such that the hash of the new documents to be added and the old documents is smaller than the threshold. That's what all the miners are computing in parallel. Whoever finds a nonce first, a nonce with this property that the resulting hash is smaller than the threshold, hurries up to broadcast it to everyone else such that they start working on the next block for the next 10 minutes because the problem was solved for this block. Okay? If the nonce is not announced fast enough, then it's, the miner that found it is losing, because it means that the rest of the world will not start to use the most power, the big computational power they have to extend your nonce. So your nonce may be lost in irrelevance. And why you don't want the nonce you found to be lost in irrelevance? Because among the documents you add, each miner adds a special document which gives him some money, some bitcoins. So if you are the one that found the nonce, you found it for a set of documents. Besides each, there's a document saying you win a certain number of bitcoins. So you want your nonce to be the one that goes faster and is extended. So you want to publish it as soon as possible. Nobody can steal it from you, because if they will steal it, they will steal a nonce that is giving you money. So you win. Right? That's the idea. So you start from the Genesis block, and everybody hurries up to build new coins. So it can happen that 2 miners find relatively simultaneously a nonce, but the one that was the fastest to distribute it, okay, gets his one picked, and the other ones are lost in irrelevance. They are called anchors. And again, sometimes somebody else finds that probably this guy manages to distribute his nonce fast to some people that will build on top of it. But if you distributed yours to more people that have more power, this one goes faster, and then this one again is lost. So because everyone tries to extend the longest chain. Because if you extend the longest chain, it's more likely yours will be on the right path and get authorized. And the money you won like that will be established. Okay. So yeah, you have miner software for all the various coins. For example, for Ethereum, you have these programs that you can obtain on a Mac, for example, with those commands, and you can just execute from your command line. Now, typical computers are too slow nowadays because people have developed specialized application-specific integrated circuits which are very fast to do this hashing. They just do this hashing in parallel, so they can do it without consuming too much electricity. And since there are a lot of them, they are going to be able to generate bitcoins with cheaper than you could ever do it. So the prices have risen so much that, and the computational power has raised so much that our computers would be very inefficient. You would just lose money trying to mine. Okay, for a while the Ethereum didn't have specialized computers, but now one has developed for them as well. So it used to be feasible to mine with your own laptop for Ethereum for a while, and also for Bitcoin at the very beginning, but now no longer. You might have heard of wallets. Okay, so wallets can be online, or you can have them on your computer if you are continuously connected to the internet. So the wallets, what do? They compute how much coins you have, how much money you have on current Bitcoins, right? Your Bitcoin is not a set of bits. You don't say, this number is my Bitcoin. That's not how it works. Bitcoin, the amount of money you have, is a result of all transactions. Actually, on the blockchain, you have all these transactions. Each time you generate the Bitcoin, there's a document saying now you are given this much amount of money. When somebody's transferring money from one person to another one, there's another document added there. And your wallet, it's a computation of everything you have received minus everything you have given away, and that's what you are remained with. So we say it's a fungible value. So you don't say this Bitcoin is different from this one. They are all equal because it's not a value. I mean, it's just a result of a computation. Okay? You don't have a number. You just have an accounting that tells you that's how much you have in your account. There are mining pools. What are the mining pools? Are communes of miners that you can join, and these miners distribute the hash space so that not everybody tries the same nonces. And we are going to split the number of nonces, possible nonces, between all our people such that we are more efficient, avoiding repeated work. Okay? And then they are going to split the money between everyone, proportional with the amount of work, for example, that your computer is putting there. One can check that you really work on the nonces that you are given, because you have to submit all the hashes, and they can be tested, that you computed. Computing of hashes is difficult, testing them can be done probabilistically, so that can be efficient. There exist exchanges out there. Exchanges are platforms that support the addition of documents. If you want to notarize a document, okay, like a transfer of Bitcoin or some other kind of document, you give it to this exchange, right? This exchange can post it such that miners add it to their documents for which they try to compute nonces, and whenever they compute a nonce, they notarize your document. And these exchanges can notarize documents, can add transaction between different Bitcoins, transaction between the different people, between and so on. So now, if everything you have is a hammer, it's a blockchain, everything looks like an egg, right? And we have other tools for doing computations online, like we had the internet, the cloud, we had other kind of peer-to-peer technology in the past. But everybody's trying to try the new toy, wants to try the new toy, right? So how you can use a blockchain? Right. Well, you can look at the blockchain like a shared database. Now, it's a database of tokens that everybody can see. It's the same. It's shared. Okay. From a legal perspective, the tokens, the documents on this chain mean nothing legally, right? Your transactions there could be seen. Most companies say like a donation. When you should only invest as much as you can lose. Whatever money you give, it's a donation that you give. It's not a security, not an investment. What are the tokens that you can put in the database besides some Bitcoins and transactions? Okay, you can have what is called a colored coin. A colored coin. At the beginning, they were actually satoshis, the smallest denomination of the Bitcoin, that were made special. How are they made special? They are not numbers with a special pattern, because Bitcoins are not numbers. They are actually values for which a special property was declared in the document for awarding them or for transferring them. And a contract is out there between the miner saying that all the documents legalized will only transfer money colored red or green from somebody that had it in that mind, and one in the document that generates the transfer, one says that one decrements the amount of green coins he had before. Like that, this kind of contract guarantee that green money remains green money. That's actually not a coin that it's green, but the counting will sum up such that whatever coin is colored remains colored. And nobody can create them except who's allowed for the issuer. So that was the original way of doing it. So it was now it's can be done in completely different ways. For example, with Ethereum, you just declare a variable, and you have smart contract programs that increment those variables, decrement them according to general rules, and it guarantees that one maintains the values according to the definition of these tokens. How can you use the tokens? Well, some tokens typically could be seen as an agreement on something external. So you say, this token represents that good outside. I'm telling you that I'm selling it, that you have it. Well, if you have a legal support of on that, it matters. If you don't have a legal support, then it's just a gentleman's agreement. But it could be something intrinsic, like the keys of a car. You could have your car as electronic recognize a blockchain. And it knows that when the money is put for selling that car to you, then you are allowed to start it. So when you have paid for it, then the car accepts to start. And until the transaction of you buying the car is not on the blockchain, you could not start. So that's how you could use the blockchain to have an intrinsic way of using the tokens. Okay? Or they can be the currency for a closed community. Okay? You have several types of tokens. So you can have intrinsic tokens, like the ones that make the blockchain work, like the Bitcoin or the Ethereum currency itself. It's a kind of token. Or you can have assets or utility tokens, namely some that represent something outside, like goods, music, votes. Okay, you can represent whatever you want on your blockchain, and they can be created, bought, transferred, redeemed, and represent assets if somebody recognizes legally. Okay? Or it can be just an agreement between the users enforced by a company that actually owns that music that they are selling. So what are the properties that you can use for the blockchain? How should you take it? Typically, applications using the blockchains are not optimal of guiding decisions. If you just want to give advices to people, that's not what the blockchain is for. You can use a website for that. They are for making decisions. They are for committing. You commit to documents. The blockchain is there to actually decide who was the one that owns an asset, who was the ones that bought it, who was the ones that created it. So another property is you should imagine it as a shared memory. You use it when you want people to agree on who's the owner of something. There's only one blockchain of a type, and there's only one owner of an asset. This bit, okay, this amount is only yours. This good is only yours. It's decentralized. It's good for decentralized databases. Persistent, at least 10 years so far. I don't know if that is approved for 1,000,000 years or for 10 more, but 10 years has been around. Eliminates the need of trust. You don't need an escrow to keep the money in an account until somebody gives the good. You can make what is called a smart contract, which is guarantees that as soon as you put money in an account on the blockchain, automatically the miners, in order to correctly validate the next blockchain, perform an additional transaction. Okay, so it's very powerful from that perspective, very good for contracts. But you also should know, if you lose your keys from your wallet, from your account in which transactions are being made, then you lost it. I had myself DigiCash, one of the first type of digital cash out there, back in '98. And I was trying to experiment on it. I was still a student at the time, and I've lost it. So I've lost the cash, that's it, it's gone. And they say that a large percentage, like 20% of the current bitcoins out there already are lost. People have lost the keys from them, so they just don't exist any longer. It's easy to lose them. I was looking for my card and no longer find it. Okay, so another kind of limitations is you have a fixed update rate. So adding new data into that blockchain only each 10 minutes. You cannot update the database faster. If you need a database that's very fast, probably it's not the one for the Bitcoin, probably for another kind of currency or something else. Okay, 14 seconds is for Ethereum, right? So it's a little bit better. There's a maximum update size, only 1 megabyte per 10 minutes. So if you want something that is more dynamic than that. With Ethereum, there's a limit in terms of the effort done by the miners to compute the contract and to verify the operations that they do. They compute it in gas. So 1.5 mega gas is the number of operations that can be performed in one block. We look at a couple of applications of blockchains. I found some on futurethinkers.org, and I have added a few more that I encountered. So banking is the most trivial ones, right? Sending remittances is what you'd expect a blockchain to be for and the Bitcoin to be for. Cybersecurity, it's for eliminating the middleman, so like Namecoin not having a centralized domain name server, BlockSign is for digital signatures. Artifacts AI is for publishing your paper, so if you are afraid you send your paper to a conference and that somebody there will steal your idea and will not publish, will reject your paper, okay, you can submit it to the other blockchain. There's a company having a business on that, and like that you guarantee that forever, if Bitcoin lives forever, your document is registered in the blockchain. Supply chain management, IBM has got into that business too, to guarantee that the products you buy come from, the diamonds you buy are real ones, food you buy is fresh, and so on. Forecasting, guaranteeing that you cannot change your bets such that they match the winner, so once you bet, you commit to your previous bet. They are on the blockchain. Internet of Things devices, to eliminate centralization. Identity verification for insurances and guaranteeing that what the insurance committed to paying is what they are going to. Private transportation, ride sharing, commitments, contracts between people sharing transportation. Cloud storage, charity, proving that the funding you give is going to be used as intended. That's a big gift company. Voting, committing to a vote. So, government, Dubai said they are going to put all their documents on blockchain. Distribution of public benefits, universal income mechanism, healthcare, right? Securing sharing of data, guaranteeing that the privacy is maintained with the hashes that you give access to people that want to do statistics based on patient data and so on in a secure way. Energy management, music licensing, retails, even Walmart is having some developments there. Real estate, blockchain is very good there. We can see who's the owner of the house. Nobody can cheat you and sell it twice, and there's only one contract out there. Crowdfunding, if you want to get the funding money to achieve something, you typically commit that if you don't get more than, 2 million, you'll give the money back. This would be automatically done by smart contracts without anybody's specific action over there. Just the contract will say 2 million are not getting this amount, obtaining this amount of time. The miners have to, in order for the blockchain to be valid, they have to make the transition backward. So, news, decentralized news, less fake news. Right? Political parties, we see a little bit more how they think people can make political parties that target and commit to vote what people have asked them to do on blockchain. Actually, there exists something like that out there. So we hear talk about virtual societies and startup cities. What is that? BitNation is an organization with 2,000 people that have citizenship over there. And they declare themselves a virtual society. They have virtual money and so on. There's BitPesa, right, a foreign currency exchange that would support the exchange of currency in such a virtual society. Their anonymity can be enforced by the darknet, right, Tor, Freenet, CGDNS, it seems like, but in reality, all the exchanges have to comply with the countries where they are located. Okay, so we have seen that, right, Petro, a couple of weeks ago, was made illegal in the US. They cannot just act, it's the country where they act once they're illegal. So this was a proof of the fact that one cannot, in this virtual world, live completely in an abstract way with respect to the countries, physical countries. In order to have decentralized virtual societies, the following pillars were considered important: communication, virtual communication laws, which that's achieved by the blockchain itself. The laws is achieved by actual voting mechanisms we have seen that a lot of companies promise to offer on the blockchain. Production, all the companies we have seen can offer products on the blockchain. Finances and currencies, obviously this is what the virtual currency is about. So it seems it's almost done. And the principle that works with decentralization is the following. You never change things by fighting the existing reality, right? That's what somebody said. To change something, build a new model that makes the existing model obsolete. So this is kind of the energy that moves the people that have a vision related to the blockchain. So we'll build a virtual society on the blockchain, and it's just going to be so much better than what is out there that will make the current one obsolete, and people will just follow our decentralized society. Okay? It has been tried in the past. It's not the first time that you have idealists like this. Diaspora was another peer-to-peer system that had existed 10, 15 years ago, but failed for lack of funding. Blockchains add the funding. There's the money that's intrinsic in it, and that made the system work much more than any other decentralized system has done before. I'm particularly interested in voting. Also, the blockchain has been one of my interests and research for a while. So in order to have a meaningful voting, for example, of a blockchain, you need institutional commitment. Somebody has to say that he's going to care of what you vote. Otherwise, destroy your votes and nobody cares about them. Identity verification. So if you know who's voting, if they have a right to vote, it changes on how on the meaningfulness of the vote. And the ballot counting should be done right. These are all very difficult problems. There are some companies out there that make a lot of noise that they are solving it. So there's MeVote. In Australia, they say, well, people will just post items to vote on their system together with some text to brainwash you. In order to vote, you'll be forced in their vision to first read this brainwashing text that tells you to vote in the right way and gives you the right information, such that they prepare their mind right before you vote. And once your brain is ready to vote the right way, then you're allowed to vote. And then at the end of some time, they announce everybody how. This is their vision of how the right democracy should be, right? So everybody with his vision. There's democracy.earth, who has their own idea of the sovereign system in which, again, on the blockchain, people will get items to vote on, and if they, based on how they vote, some parties in their country promises, like the Pirate Party, that is now at fashion in Europe and South America, promises to vote whatever the blockchain result was for voting. Okay? So that's political parties based on the blockchain, and it seems to be pretty at fashion in some countries. think Germany had a very powerful pirate party, and several other European countries, and Brazil, I think is strong there, or Argentina too. So MIST, it's a graphical user interface actually built by the developers of Ethereum themselves, and they promise you that you can build your own democracy in 100 lines. Your own democracy for your club, your group of friends. You'll have your democracy. You vote together on this system, and you'll have here the results of the votes and proposals and so on. All nice, right? Just a small trick. It tests in 100 lines, and 100 lines means 100 lines of code. And I don't think really everyone can do this. It's not really for everyone yet to do his own democracy there, because that code is relatively complex. But probably once, so way to go. There's an important impediment brought by Ehud Shapiro in World Economic Forum 2016. He said, well, the internet now is just a masquerade. Actually, you don't know really the identity of anyone. So who votes? How can you know one that didn't vote 100 times? It's very difficult. There's a promise from some important institutions that by 2030 we are going to have trusted electronic identities for everyone. We hope. At that moment, probably there's going to be some meaningfulness in the votes. So how do these companies work? All these systems you have seen in these last few slides. Well, the concept is based on the so-called initial coin offerings. Okay, it sounds similar, but it's not the same as an initial public offering, right? So laws do not apply. The documentation of what you give your money for when an ICO is issued is probably just a web page. And the number of tokens is put on the market. And at that moment, that's all you know. How much money they claim they got, like Venezuela claimed they got, I don't know how many millions in sell. Okay, it was published later that it's a trick. They had some agreement to say that they sold their tokens more expensive than they actually were. You don't know the identity of the investor. Actually, the ICO issuer can buy himself the tokens and claim that he has gathered funding, right? It's not like with public offerings. So you should know all these differences. What are the smart contracts? The smart contracts we mentioned are addresses or accounts that are associated with code. You can do that on Ethereum. So you write a code in a programming language, a code that, for example, moves money from an account to another, or generates certain documents that should be legalized, like giving goods to someone. And when certain parameters satisfy certain values, and you put that on an address. And then you put money into this address. And whenever somebody puts money into this address, makes a transfer of money into this address, then miners can get that money if they execute the code, if they generate the document specified over there. This is what a smart contract is. And this is at the base of all this blockchain virtual society, right? So you no longer need contracting clauses. There's a guarantee that as soon as the clauses are satisfied, the conditions are satisfied, the first miner that sees that will hurry up to generate the documents that are needed in order to get the money that's associated with the contract. Okay? Are there problems there with the applications? Yeah. For example, the decentralized news network, they say, well, they are going to use the blockchain to have a fair mechanism for generating news, which doesn't have fake news, is not controlled by conglomerates, and has resistance to gag orders and so on. But if you read the details of how they plan to work, now the founders will own 10% of the stakes continuously. Each month they'll get 10% of the rights to write news. So that doesn't look like democratic news where everybody can write. Okay, you have reader, writers, reviewers, publisher, and you have super reviewers. The super reviewers get to decide what can be published and what cannot, and who the others are more than. So that's a little bit more like in classic journals. And you have a complex economy, like tipping, paying for rights, getting paid for a reputation of agreeing with the majority. So if you agree with the majority, you have the right to write more and you get paid. If you don't agree with the majority, you have a minority view, you are not allowed to write, and you will no longer get funding for your, or rights to write for your articles. So you see there's, and more than that, you cannot withdraw articles, you can only publish sourced articles, okay, with their system. So if you can only publish source articles, it means that you can only publish articles that were not subject to a gag order, so their promise to resist the gag orders is not really achieved. Therefore, there are a lot of promises that look nice, but there's no law enforcing this virtual society, so you have to verify for yourself what you get into. And right, there's a bigger problem with a chain, with a blockchain inside, the problems that have to be solved, like the cost of the consensus. In January, the Bitcoin was consuming as much electricity as the whole country of Denmark. And it grows 25% per month. Okay, so by now it's probably 2 times as much as Denmark. So solutions are needed, right? The people talk about introducing proof of stake and proof of importance and used by some minor cryptocurrencies out there, but they have other problems like centralization easily possible, easier than with a proof of work that is currently used by the blockchain proof of that you try with many hashes. So I don't know what is democracy, right? Then the more smart contracts are not really verified, that people really achieve them. There's no good verification implemented in the software. Scalability, the bandwidth is still small for a lot of the applications out there. You have noticed probably the slow speed of update for the blockchains. So there are a lot of other technologies being promised out there. It may come, it's on the way. But still there's a lot of work ahead. So if it does not work, what we have to take the third one, right? That's what my dad used to do. Yeah, and to finish on a happy note, I found a few nice internet icons that, yeah, for disclaimer, they are fun, but no relation with reality implied. So you are here, but hopefully you will be there. If you are a hodler, you keep to your money, you will probably get like that rather than like that. If you are panicking, you will probably get there. It's at least an opinion. And the other kind of opinions, right? That's the new soon. Cryptocurrencies, mining, devastates the terrestrial resources, boom. My first planet coin. So, yeah, that's the kind of. Do you have questions? That was an introduction about.
Why does it fluctuate so much?
Why does it fluctuate so much? Because it's free market, really free market.
Will it ever be stable?
Will it ever be stable? This is a very deep question, and I have frequently thought about that, and it could be. It could be. It depends a lot on the economics. There's a very fine economic out there. Now most of the actors involved are actors that are trying to just get money by having the price rising, right? So if most of the people there speculate, then automatically the kind of market generated by speculation is going to be a fluctuating market, and you are going to have that kind of behavior. Now, if a lot of real services, like the ones you have seen over here, right, are going to, to actually take place, and people will pay money to get their products verified, that they come to whoever they dream them to come from. If they are going to pay to be willing to give money such that their crowdfunded funds are correctly allocated according to the principles. If they are going to really start voting and pay money for their votes to be counted with this system. So if all of these, at least some of these applications will have real success and will make people pay for the Bitcoin just for the service it offers, there could be a future. Probably not with a Bitcoin, probably with some other coin, probably with that bigger technology that eventually will break it free. So it may eventually reach it, right? So it all depends on the success of all this research. It's a research area. It works very well for researchers. And most of the people investing over there, I know there are a few that just speculate and they actually don't know what they are doing. But there are some that are there just because, especially in the smaller currencies, that are researchers and or interested in something. And if the actual percentage or amount of people that know what they are doing is going to be large, stable, and they are paying for a real service, I think there's a future for it to be a stable, for some kind of cryptocurrencies to be a stable currency. Yes?
So you mentioned that it has a fixed update rate of every 10 minutes.
Right.
Is that regulated by the software, or is that controlled by the founders of the original program? And do they have control over shutting it down in any way or manipulating it in however they feel like because they're the founders? Or?
A very good question. No, the founders have no power there. We don't even know who the founder was, right? For example, Satoshi. Nobody knows who he was because he published everything anonymously. And there's a guy from Australia who claims he is, and people are mocking him, and he's not, it seems, at some conferences. And some people, some other not. It seems not everybody has been convinced by his proofs, and he was not able yet, it seems, to use the money associated with the founders in the original issue. So we don't know who the founders are, and their code has changed. They wrote something like a few thousand lines of code, and now there are hundreds of lines of code there, around 100 lines of, thousand lines of code in the Bitcoin miner, right? So it's not the founders that control it, and there are now all kind of volunteers to generate new code, and who controls it? It's these guys over here. Right? Let me come to that picture. This controls it. You generate a block, and if the other people don't build on top of it, you lost it. You didn't generate anything. The community who choose to build on top of your block, they decide. If you get a new rule saying the Bitcoin will update every 5 seconds, okay, you code it, you publish that piece of code such that everybody uses it. If they don't use it, and they don't extend on the code you generated like that, then you just lost your effort. If the whole world of miners and exchanges decide to go with your code, that's it, that's a new change. So that's a kind of democracy, or a consensus that it's building. It's not real vote, it's a vote by action. If people just follow you, then you are there. If they believe your solution is the one of the future, it's, that's just going to go up, and that will be taken. Nobody controls it. Well, that's a way of saying it, We say nobody controls it, and a lot of people believe it, that it means we have a real virtual society that is free of the real physical world. Is it? I'm not so sure now. If large countries would decide to forbid something one way, they say, it's like US, the petrols, you cannot exchange them in the US. There are not a lot of countries do that, you cannot do this and that. Then probably the mass of people that would have the courage to do it anonymously will be too small to matter, and it's lost. So now there's an effect that large countries can have, there's an effect that large economic societies can have on top of it. Difficult to quantify, it's very political in a way. Yeah. Yes?
You talked about miners, so every cryptocurrency, do they have these separate miners, or can a single miner make hash codes for Bitcoins also and Ethereum also and others?
if by a miner you mean a program, typically each program out there is computing the hashes for a single blockchain. If by a miner you mean an owner, you,
A machine, by my I mean a machine.
so the machines are typically specialized. For example, most bitcoins now are generated with ASICs that only know to compute the hash according to the formula for the bitcoin, right? So then it means that's the only thing that they can do, because they were hard-coded like that. If you generate a machine that has 2 CPUs, 2 cores, and one does Ethereum and one Bitcoin, then they would be able to do it like that. So it's as you design, you can put it in the same computer. Now there are also discussions of merging some blockchains. Now there's a possibility that in the future there's going to be an agreement, and the miners for Bitcoin and the miners for Ethereum and the miners for something else would start generating at a certain moment in the future blocks that recognize both coins with a given rate of exchange. And suddenly you merge the two. If the society arrives at this, everything is on the hands of the society. You cannot play. It's the result of the negotiation between people, politics, economics, everything there. It's kind of a democracy where the control is complex. Yeah.
So is the Bitcoin just one blockchain like that, and it just keeps on spitting out more coins as it continues
Right.
going? Okay.
Bitcoin is one of those. Ethereum is another one. You can take the blockchain, give it, and make a private version. Some group of companies can take the algorithm and run it just between themselves, and then they have a private blockchain. People say it's not useful. It's database would be better than that one. Would be faster, a simple database, because the real power of the blockchain is this openness, which guarantees kind of the commitment that nobody really controls it. If you have a private one between a few companies, then probably one of them or 2 of them control it. So then it's like why not putting a simple database that's very fast on the server of one of them, and that's all. Still, a lot of banks actually aggregate to do it just because it's cool. So you will hear their news that, 3 banks are using the blockchain to design something rather than using a database. Yeah, they can.
So in Bitcoin, is it presented like one coin? Is it represented by one block or a combination of multiple blocks? So where is like one coin resides?
So what I said at a certain moment, a coin is nothing. That is not a set of bits. It's not residing. A coin is the result of the computation on transactions. There are documents on the blockchain saying somebody gave you 100.1 bitcoins. There's another document saying that you sold half of a bitcoin to him. And the result of summing all this up in a wallet, a program that just gets all those documents for you, sums all the amounts, subtracting whatever you gave, is telling you the amount you have. So your bitcoin is a set of documents of transactions that you performed.
So after 1,000 transactions, all these 1,000 transactions needs to be verified.
The whole history has to be verified. The whole history since the creation of the Bitcoin is telling how much you have, which is telling you one of the problems of the Bitcoin, scalability. Right? For now, still, we have a pretty large amount of data to store all the history, and that's going to keep growing. Right? So, computer scale, we have Moore's law, hopefully storage scales as much as the time passes, but there's going to be, that's a challenge over there. Yes?
Is it possible to have a blockchain that doesn't use a token at all?
A blockchain without tokens. So would be that was the original technology. So the blockchain, the chain of hashes without blockchains, they didn't have tokens. So the concept of chain of hashes to store history did not have the tokens. That was the original old idea. Blockchain was just the idea of adding tokens on the chain of hashes. So the idea they existed for a long time, but since there was no token to give incentives to people to try to have those tokens, all right, then it was not making noises and was not in the news. Yes?
Is all of the mining brute force, and do you foresee any possible innovation there that could be more efficient?
Yeah, it's all brute force, and it's by design brute force. It's because hashes, we know there's no solution for them. Nobody has found a solution for them, and it is believed that there's no solution to do them other than with brute force, right? A lot of other hard problems out there may be solved by quantum computing or something. Hashes are supposed to probably not be solvable by quantum computing. It seems, we have no proof, no guarantee, but currently it's one of those technologies that we believe even quantum computing may not address it. So it's kind of safe to make a proof of work. Now on the other side, everybody is trying to move away from proof of work because of the amount of energy it consumes, right? To proof of importance, proof of storage, proof of a lot of other things. They have other weaknesses, but in that case the hashes will be forgotten from that perspective.
So the only way that you know of actually getting an edge is either specialized hardware or using pools to efficiently do the work.
Thank you.
Thank you.
No other question.